Hello and welcome to the UNI.MINDS Festival. My name is Jana and I'm really delighted to be hosting this workshop that is part of UNI.MINDS Festival. The mission of this festival is to strengthen the academia and industry partnership and grow the innovation community in Slovenia. You can find more information on the festival on UNI.MINDS and the UNI.MINDS session on the event website and on the Huva app. You will find the links in the chat box. You are all invited to use these nice UNI.MINDS theme backgrounds that you see we are using and to download them. And we would also very kindly ask you if you can put your camera on so we can see you and feel more interactive with you during the workshop. Today's workshop will be focused on classification models and how to interpret the models, and it will be led by Ida Pretner. Ida Pretner is a researcher at the Faculty of Computer and Information Science and a PhD candidate at the Department of Ethnology and Cultural Anthropology, both of University of Ljubljana. Her research interests are the methodology and interdisciplinary research and the application of the techniques of machine learning and data mining in the humanities and social sciences. We encourage you to use to ask questions and to use the chat box, and we will try to answer them all, whether through the workshop or at the end. And we hope you will enjoy. And I will now stop sharing the screen and I will give the floor to Ida.
Hello, everyone, and welcome to the workshop. Thank you, Jana, for the presentation. So today's workshop is aimed at being very practical. So I hope that at the end you will be able to do some small, short analysis on your own. So that considered, I ask you to ask questions if something is unclear, because the main goal is for you to take something practical away from this. Okay, Jana, now we can start a poll. I just want to briefly know what level of data mining are you? So are you a beginner? Do you know something about data mining, or are you already an expert? Okay, so now I will share my screen with you. Okay, so for today's workshop, I will be using software called Orange. This is a data mining and machine learning software that we develop at the Laboratory for Bioinformatics at Faculty of Computer and Information Science, University of Ljubljana. And so it's aimed at simplifying data analysis workflows. It's based on visual programming, so every analytical step in the process is packaged in a widget. So a widget is a step in the analysis, and we place widgets onto the canvas and we connect them into an analytical workflow.
Ida, do you see the results of the pool now?
Yes, I see there are mostly beginners.
I will stop sharing now the results.
Great. Thank you. So perfect. This workshop is aimed exactly at beginners. So if you have downloaded Orange, you can work with me. If not, that's fine. You can just observe. So I think at the beginning, you see something like this, a welcome screen, which you can close. And then you see a window like this. So this is, the white part is called the canvas. And on the left side, you have a couple of sections. You probably have less than I do. So these are panes that if you click on a pane, you will see a collection of widgets, a collection of components for each step in the analysis. So data components are gathered in this pane, and here we have visualization components, modeling components, and so on. I will hide this for simplicity. So now I have them here. And I will start by loading the data. I will right click on the canvas and look for datasets widget. So this is the first component that I will use. It's called datasets. If I double click on the icon, the window will open. And here I have a collection of datasets that I use for teaching or for experimenting with my models. Okay, so for today's workshop, we will be using a dataset called attrition train. So select this dataset and double click to load it. Now I will go from this right side where there's this little ear. I will click and drag a connection out of it, and I will connect data table to this widget. A data table is a simple widget. It's like an Excel spreadsheet. It enables us to observe the data. So in this data table, I have 1,470 instances or rows or samples and 18 columns. So this data set is, you can imagine this data set is from an HR department. So Human Resources Department sends this data about its employees. Each employee is in a row. So this is one sample. And an employee is described with age, whether they travel for business, the department they're in, distance from home, education, gender, and so on. So each employee is described with 18 features. And I have 1,470 employees in my data. What is special about this data is this gray column on the left side. It's called attrition. Attrition means when someone quits the job. So if an employee quits, this is called attrition, people leaving your company. And every company wants to keep valuable talent because companies invest resources into people, and losing talented employees is not considered a good thing. So in this column, we see whether an employee left the company, whether they quit, and this is a yes, or whether they stayed in the company, and that is a no. And the reason this column is gray is because it's a special column. So this is called a target variable, class variable, dependent variable. But essentially, this is something we would like to predict. So in predictive modeling, the aim is to take the data and to predict something at the end. So here we are predicting whether a person quit the job, quit from the company or not. And this is called classification. This is because we have categorical values. So a value is either a yes or a no. If we had a numeric variable, something like age, this would be called regression. But today we will be working on classification, namely trying to predict from these columns here whether a person left or stayed. And this is called classification. Okay, so we have seen the data in a data table, but this is not that interesting. I mean, if I open it, okay, I have a bunch of numbers, some values here, but what we really want to know is what this data tells us. something like some valuable information. And for this, at the beginning, I always like to use visualizations. One of my favorite visualizations is called box plot. So I will again connect another widget and start typing box plot, and here it is. So you're probably familiar with the box plot. It shows kind of like distributions of the data. So it shows the mean, the median, it shows standard deviation, it shows the quartiles, so the first and the third quartile. So it gives us essential information about our variables. Here, for example, we see variable age and how age differs based on this attrition attribute. So an attribute is one column in the data. So you can call it an attribute, a feature, a variable. So if I'm using different words for this, don't be confused. It's the same thing. So we have split this by attrition. So at the top, we have people that left the company. Attrition is yes. And at the bottom, we have people that stayed. Attrition is no. And this shows us age values for these two subgroups. And we see that people who left the company are slightly younger than people who stayed. So this is a first hint at what the situation might be. Another great thing about this, well, essentially about Orange, is that I can ask for informative visualizations. So imagine I have lots and lots of attributes, like 100, 1000, and I don't know which one to look at. I would have to go through every single one to find something interesting. So to save us time, Orange can do this. So I asked it to split by subgroups attrition. So the split here that you see is by our target variable, so what we are predicting. And now I will select this option, order by relevance to subgroups, which will order my features here, my variables, according to how interesting they are for attrition. So to say this in another way, how well attrition, how well this variable is split based on attrition. Okay, let's see this in practice. So here I have people who stayed and people who left on the left side. And each line is then further split by overtime. So whether a person works overtime or not. And people who left the company were working more overtime. So the split here is based on chi-square or ANOVA, in this case, the chi-square value, which is a statistic that tells us how well this variable, how pure the split is if we, so pure in the sense that how different the distribution is if we split by attrition. And here you see that there are many more people that work overtime in the attrition category yes than there are in the attrition category no. So this is a nice way to observe interesting features without going through all of the variables in the data. So now we have two pieces of information. People who leave the company are generally younger and they work a bit more overtime. So of course, I can also observe other features, but we will leave this for later. You can do this at home if you want. So this is just the first step in the analysis. I always look at the data in a data table, and I use one or more visualizations to look at the properties of the data. Are there any questions so far? Okay, if not, we can have a Q&A session at the end. So now it's time to do some predictive modeling as promised. So first, if I look at this, first I will have to find an algorithm. So I need an algorithm. That's the idea of machine learning, is to use an algorithm, or in other words, a procedure that figures out a pattern based on these 18 features and tries to predict the final target variable. So an algorithm, a classifier, we call this a classifier if our task is classification. So a classifier tries to find a pattern in these 18 features that successfully splits data instances into attrition yes and attrition no. You will see what this means in just a moment. So one of the simplest but also quite powerful classifiers is called logistic regression. So now I will connect third widget to datasets, and it's called logistic regression. So logistic regression essentially is like a recipe that takes white, that takes columns in white and finds a pattern that fits this attrition, as said. The specific of logistic regression is that, so if you imagine that every data point, every worker is a data point, like, for example, just for easier visualization. So for example, let's say this is our data. So every worker is one point in this space. And here I have, so blue dots are those that stayed in the company, and red dots are those that left. So now what a lot of classifiers, not all of them, but logistic regression certainly does, is it tries to find some kind of split between red and blue data points. That's what it does. Of course, here, as a human being, you wouldn't be able to draw a line, a simple line, and just cut red points from blue points. Of course, the data space that we talk about has 18 dimensions. So 18 dimensions because it has 18 features. People cannot imagine 18-dimensional space, of course. We can imagine 3, maybe some very creative people 4. But so 18-dimensional space is very complex. The picture that we see here is a simplification and like of all these data points into 2D space, just so that we can better see the data. But if you can imagine, you know, this logistic regression would try to find some kind of hyperplane. It's like some kind of cutting, like if we take a piece of paper and we try to put it between blue and red data points. This is what logistic regression does. And actually, logistic regression is a part of a category of models that are called linear models. So they try to find this hyperplane between blue and red data points. And logistic regression transforms, so it uses a logistic function to transform the distance from this imaginary paper that we have put between blue and red data points into probabilities. So now this sounds very complicated. Let me just try to show you, oops, not like this. So if I use this drawing board, let's say, so let's say these are my data, and logistic regression tries to find this diagonal line here that would split blue points from red points. This is it. It's a mathematical function that splits the data in two. And logistic regression is very popular nowadays. It's used, I mean, it's used as a part of neural networks. So neural networks are stacks of logistic regressions with some hyperparameters and pooling functions, but essentially in their very core, they're based on logistic regression. So now what? Okay, now I have my data, I put it into logistic regression in this recipe that tries to find some kind of pattern in the data. And now what? Where do I go? So logistic regression is great because it is one of the classifiers that we can explain. And this is the core point of today's lecture, how we can explain the models. Because often it happens that okay, you're in a data science team or any kind of data analytics team, and you build a model, but you get a great result, you get a great accuracy of the model, but you don't know how it works, what it does, like why things happen. And I think it is also important to know why certain things occur. And today we will try to discover this. So the way to show how logistic regression works is called nomogram. So nomogram is essentially a visualization of model coefficients. So
okay, Ida, we have a question that maybe could be answered right away.
Yes.
Janja is asking if there is a difference between this and MS Excel solver.
Okay. So a difference between, I suppose, Orange and MS Excel solver.
Yes.
So I don't know Excel solver. I don't use it, but from what I know about Excel, it certainly has some functions that are similar to Orange. I mean, Excel has been improving yearly, so I'm certain that some things are available in Excel. But I would say not all of them, especially more like machine learning oriented things that we will do later. So Excel certainly has a box plot, perhaps even logistic regression, I don't know. But I would say it doesn't have all the capabilities, plus Orange is more aimed at visual programming. It's supposed to be a simpler way to do analysis, I hope. Thank you for the question, by the way. So here we see nomogram. And I will try to explain what we see here. First, I will change this target class. So here I'm just asking this nomogram to show us probabilities for no, so people that have not left, and I will just change it to yes, because I want to know what is specific about the people that quit the company. So that's it. If you see the visualization, it's just mirrored, because these are exact opposites. In some more complex applications, we would have different features, different lengths, but here it's just the other way around. Okay, so now I'm looking at probabilities of target class yes. What does this mean? So I want to know what affects people, what is specific about people who left the company. Here I have, so the things I see here are my features, my variables in the data. So we saw this, we saw age, we saw overtime. These are all the things that we use to describe these people, our employees. At the top, you will see the variable that is that has the biggest contribution to the final decision. So this is years, and then these variables are decreasing in importance, which is evident from the length of the line. So the longer the line, the more important this variable is. So for people leaving, according to logistic regression, the most important attribute is years at company. So the amount of time people have been with our company is the most important thing for determining whether they will quit or not. And so here we see that the highest value, so the employee that has been with us the longest, has been with us for 40 years. And people who've been with us the shortest amount of time, it's 0, of course. So what does this mean? Here I have this point and like this blue dot, and this, so at the bottom here, I have a total, so here above, at the top I have points. I'm trying to collect points. Each attribute in logistic regression gives some points to the final score, to a person leaving or staying with us. The more important the variable is, the higher it's ranked here, the more points it will give. Actually, not more points, but the points that it will give will have a higher importance. So the most important attribute is years at company, and it will give 2.87 points for the final score. And then these points are mapped here. So the total is 8.8. So now at current moment, I have 8.8 points. And these points are then mapped to the probability, the likelihood in some way of the person staying or leaving. And the probability that the person will leave at the moment is 8%. So it's very low, very unlikely that people leave our company. So this is, so the points now here are set at the average value. So this is the average person, okay, what you see here. But what happens now? I click and drag this point to the right. So now my person, if I change my person, the person has been with the company for a very short amount of time, let's say less than 1 year. Now I get 3.43 points. So a lot more than I had here. And I said, I want to collect as many points as possible. I want to collect more points. But what does this do? If I get more points, I will have a higher probability of the person leaving. Now it's already at 13%. So what does this mean? The shorter amount of time the person is with the company, the more likely they will quit. But still, I mean, now we're at 13%. So, okay, it's not just years at company. There are some other factors that contribute to the person quitting. Also, how long has it been since this person's last promotion? So well, of course, these two, if you see logically, they're like the opposite. So if a person is with a company for like less than a year, of course, it cannot be that they haven't been promoted for 15 years, because this is, you know, of course, it doesn't make sense. So now we have to interpret this with an or. Either the person is with us for a very short amount of time, so these are people that are new, or if I drag this, now my probability at the bottom will also rise, or I haven't given promotion to these people for a very long time, for like 15 years. So now I have two pieces of information. The new people, maybe they don't feel that they're a part of this company yet. So now I have to work on building a community. On the other hand, I also have to consider people that have been with us for a very long time and I have not promoted. So maybe it's time to think about promoting people. And here is an attribute we saw already with the box plot, and that's overtime. So if people work overtime, it also affects the likelihood that they will quit. So now you see that the probability of a person quitting is 85%, which is already quite significant. It's a lot more than we had at the beginning, which was 8%. So what does nomogram do? First, it lists attributes by importance. So at the top, I see how important the variable is, and then the importance gets lower, and the importance is reflected by the length of the line. Also, we start with like an average person, like an imaginary average employee. And then when we change the attributes of this person, so change how long has this person been with us, how long has it been since last promotion, we also affect the probability that such a person will quit. And this is crucial for any decision making in the company. So if you want to accept some kind of measures to prevent people leaving, it's not enough just to say, okay, this person will leave, but the leadership will ask, okay, but why will they leave? What can we do about it? And this is the solution. So explainable models. Any question regarding nomograms? Has anything been unclear? So I'm trying to explain everything in as simple words as possible. If something is not clear, don't be afraid to ask. Okay, so now we already understand. I have a question. Okay, just a thank you. So now we already understand a bit how logistic regression decided, like in favor of yes or no. There is another model that I would like to mention. It's a very simple one. And it's called naive Bayes. It doesn't have any parameters. It is a very, very simple one. Well, naive Bayes was one of the first models that was used for spam filtering. So predicting whether a mail is spam or not. Now, of course, these spam filters are much better, but naive Bayes worked very well for a long time. And naive Bayes is also one of the models that we can explain with nomogram. So logistic regression and naive Bayes both work with nomogram. So now if I open the nomogram for naive Bayes, I see that the results are different. Again, I will set the target class for yes, just like before, and again, it's just mirrored over this line. So as you see, these two, logistic regression and naive Bayes, they don't agree with each other. They don't have the exact same results. And that's nice. Perhaps naive Bayes can give us a different view of the data. So for naive Bayes, the most important attribute is job role. So in which sector of the company, in which department the employee works. And apparently sales representatives are the most at risk for quitting. So if I go to sales representatives, now my probability is at 40%. And the second most important attribute is job level. So whether they're juniors, mid-level, or senior workers. And people with junior positions are also more likely to quit. This is also related to what we saw before, that younger people quit, that people that have been with the company quit more often, and this also is reflected in the job level. So even though the results are different, they still communicate the same thing. Now, I want to talk a bit about the difference between nomograms and so logistic regression nomogram and naive Bayes nomogram. So what is different between these two? Obviously, okay, these attributes are different, but it's not just that. So here you see that there's a straight line running through these lines, and these lines are organized according to the center. Here, everything is left aligned. And this is not a coincidence. This is because logistic regression works, it's a multivariate model. This means that logistic regression considers combinations of attributes. It considers all attributes at the same time. So it considers years at company and years since last promotion and overtime and job satisfaction and so on. So if two variables are correlated, meaning they communicate about the same thing, this would be considered in logistic regression. And it will give one of these two higher importance, but because of this, it will decrease the importance for the other because it recognizes that they mean the same thing. They're correlated. With nomogram, this is not the case. Naive Bayes. This is not the case. Naive Bayes looks at one attribute at a time. So just this one, and this one, and so on. So it's a univariate model. And it cannot handle correlations. So if, for example, here we have an example that job level and total working years are, well, not this one perhaps, but maybe like age and job level are probably very correlated, because if you're very young, you probably are not a senior yet. And also, I mean, okay, yeah, this total working years. Yeah, if you work for less than some amount of time, it's unlikely that you will be a manager or like a senior at a senior level. So these two mean the same thing, but naive Bayes doesn't know that. It cannot know. It just looks at job level and it estimates the probability of the person leaving or going. So this is the difference between the two. Logistic regression can handle correlations. Nomogram does not. However, nomogram shows which attributes are generally important. So it will show the total importance of each attribute separately. And this is also nice. I mean, it's a valuable information. So you can look at every attribute in the data and say, okay, this is important in this way. And here you see that it maps this contribution as positive. So here I'm going on the positive side, and it can also be negative. So it can, a value can vote against this class value. So if somebody is a manager, for example, it will decrease the probability of leaving, which makes sense, right? I mean, managers, they have like good jobs, they're paid well, so not so likely they will leave, I guess. So, and of course, nomogram works well with categorical data, as you see here. So you have categories here, but for numeric, you know, you have like less than 1.5, between 2.5 and 3.5. So naive Bayes will make bins for the data. So it will split numbers into kind of like fake categories. It will create bins. So this is one bin, another bin, and so on. And this is a little confusing to interpret. So either like it's less than 1.5, it's 1.5, or between 1.5 and 2.5. So this is not, it's not well organized. While here you will see that if you look at logistic regression, you will see that this is continuous. So from 0 all the way up to 15. And here the same, so just in the other way. So from 0 to 40. So you see that each method has some kind of like an advantage and a limitation. Okay, so now we saw that logistic regression and naive Bayes can be observed with a nomogram. But now it's time to do some predictive modeling, as promised. So what I will do, I will connect the fifth element here, and it's called test and score. So what I do is I have to find out how good are these models. We saw logistic regression and naive Bayes. They both say different things. So they have different results. I want to know which model works best with some kind of objective measure. So I will connect logistic regression and naive Bayes to my test and score. And I also need to send in the data. So what I'm doing here is I'm sending the data to this widget. I'm sending a learner, which is the algorithm, the recipe that we are working with. So both these two are learners or kind of procedures. And test and score will, with a procedure called cross-validation, it will score these two models. It will estimate their quality. It can do that because it has ground truth, because it knows this line should be yes, this line should be no, this line should be yes, and so on. So based on this ground truth, this procedure, cross-validation, can estimate the quality of the model. And you see it here. So this is naive Bayes, this is logistic regression. And each is scored with 5 measures. This AUC, CA, F1, precision and recall. And each of these measures, in each of these scores, tells us something different about the model. The most intuitive score is this one, CA. It's called classification accuracy. This is very easy. This is the percentage of correctly classified data instances. So percentage of correctly predicted employees, so leaving or going. And so it goes from 0 to 1, and this means that logistic regression is 87% correct. In 87% of the cases, it was correct in predicting the final outcome. Naive Bayes, a bit less, so 0.79%. There's one caveat here. So think about a doctor. So, okay, a good classification accuracy is 100%, right? So the closer we get to 100%, the better this score will be. Okay, so now think about a doctor specializing in rare diseases. So this is a disease that only 5% of the people get. And for this doctor to say, I have really high classification accuracy, the doctor will just say, this person is not sick. And the probability that the person is not sick in real life is 95%, because only 5% of the people in the population get this disease. So this doctor can cheat, right? It says, I'm the best doctor in town. I have 95% classification accuracy. But the question is, what is the underlying distribution of the thing that we are predicting? So if it's a rare disease, 95% is not really a good thing. It's okay, expected. So this classification accuracy should always be measured against general distribution. And this is something that we can see in the box plot. So if I look at attrition, so just attrition here at the top, and I won't split by subgroups. So I'm just looking at attrition. I see that 83%, almost 84% of the people do not leave the company. And 16% do. So expected classification accuracy is actually 83%. So anything less than this is bad. So I hope this is clear, but just by knowing how many people leave in general, I already have a baseline classifier. I know that if I randomly say to 16 people out of 100, I say you are going to leave, and the other 84, I say you won't, I will be at this approximately this classification accuracy. So this is not very good. And classification accuracy should always be measured against what we call the constant. So this is the stupidest, in quotation marks, the stupidest classifier, which just gives you expected accuracy. And here you see that the constant just predicting either majority or mean. So in our case, a majority is no, so people don't leave. And the score is already 0.83. So you see that naive Bayes in this example is worse than just the most stupid model that we can have. So, okay, classification accuracy, if this is not good, then which score should we look at? And one of the best scores for reporting model accuracy is AUC. This is shorter for area under the ROC curve, and it has like a little complicated formula. I won't be bothering you with this, but AUC is great because it's, again, it goes from 0 to 1, and it's the baseline of the AUC. So a random, if I just randomly give labels to people, it will be 0.5. So 50-50, you can imagine. So if I do 50-50, you know, yes, no, I get AUC of 0.5%. Well, 0.5. And so anything above 0.5 for AUC is good. And the way to interpret AUC, there are many ways, but I like the one where AUC essentially is if I have two people, two employees, and I know that one of them is going to quit and one will not quit. What is the probability that my model will correctly identify which is which? So this is AUC. And here we see that the AUC score is 0.79, almost 0.8, and this is pretty okay. So of course, depends on your domain. If you're a doctor and, well, if you're in a medical profession, 0.8 is not very good, you know, people will die. If this is just maybe giving some incentives to your co-workers, to your employees, then maybe 0.8 is sufficiently okay. So this is the score. So we know now classification accuracy. It's not terrible. You can still use it. You just have to report the base classification accuracy, and AUC, which is really nice because you know that if the model scores higher than 0.5, it's a good model. And of course, the higher, the closer to 1 it is, the better the model. So these two models are not terribly great. They're not terrible, they're not great either. So another way to interpret these two models is looking at a confusion matrix. So a confusion matrix shows us where the model was wrong. So now I'm looking at logistic regression, and I see here which, so I see here the true value, so the actual value of the class, so people that didn't leave and people that left. And here at the top, I see the predicted value, so what the model said. And here in this blue square, I have the correct classifications, so people that didn't leave and the classifier correctly said they will not leave. So that's good. And again, in the other diagonal, I have this like the kind of a same thing. So people that did leave and that the classifier correctly predicted will leave. Now off diagonal, I have misclassifications. So cases where the model was wrong. Here I have people that did not leave, but the classifier said they will. And there were 28 people, 28 such cases. Now this is, so if you imagine this in a different context, you own an online shop and you have a client which is, you know, still hasn't completed the purchase. And now you wish to predict whether the client will drop the basket and will not finish the purchase, or it will finish the purchase. So here, if you say, so, and the way to convince the client to finish the purchase is perhaps to give a discount. So if you give discount to people that would finish the purchase no matter what, you're wasting money, you're wasting your revenue. So here you have, okay, people that did not leave, that didn't plan to leave, but the classifier said they will. So if you give them promotion, you know, you're in a way, I mean, in the context of HR, this is a little tricky to say, but in a way you're losing money. So you gave them promotion, but they were never at risk of leaving. And then we have those that perhaps we're more interested in. So here we have people that did leave, but the classifier said they didn't leave, that they won't leave. So this is a little more like a dangerous, right? So if I fail to identify people that are going to quit, I'm losing talent. And perhaps this is this error has a greater cost. If we go back to the purchasing, to the online shop example, this means that people that will not finish the purchase unless I give them some discount. And this model failed to recognize them. So I'm losing people that, you know, I would give them 10% discount, but they would, you know, maybe spend 100 euros with me. And if I fail to recognize these opportunities, then my cost is quite high. I'm losing all the revenue that I would get from these people finishing the purchase. So this error is perhaps more important. Each error has a different cost. So to observe these misclassifications and why they happen, I can click on this field. So now I'm looking at people that actually quit, but my model said they won't. So I selected this cell. And now I can use boxplot again with a similar technique we used before. Here I will have to do something, so some manipulation. So in orange, every selection, so orange is interactive, and if I click on this cell, only these 163 people will be on the output. So the subset is on the output. I can observe this in a data table. So here I have just 163 people. But I want to observe how different are these people from the rest of them. So what's specific about this group? And to do this, I will double click on the connection, and I will not output selected data, but just data. So I will change this connection. And the data output is a little specific, and I will show you what it does. So the data output adds an extra column here, selected, and I know whether I have selected this person or not in this confusion matrix. So 163 people will have this selected label yes, and the rest will have a no. So now, in the box plot, what I will do is I will ask orange split by selected. So now I'm looking at people that I selected in the confusion matrix, so my misclassifications, and those that, and everybody else, so all these three other groups. And now, again, I want to know what is specific for this group. So I use order by relevance to subgroups once again. And okay, attrition, we know, this is self-evident, but the second most important attribute is job level. So people in this 163 people have a lower job level than people in other groups, so everybody else. So the people that my logistic regression failed to identify as potentially leaving were those with lower job levels and who's with lower total working years, so juniors, in other words. Okay, so now I've been talking for an hour and we still have 15 minutes, and I want to give you the floor and the opportunity to ask questions if there are some uncertainties, if some doubts, perhaps something was unclear, and I would be happy to talk about what we have done today, how you can extend this, and anything else. You can write the questions in the chat or just unmute yourselves and ask.
It seems everything is clear to everybody.
Wow.
That's wow, I agree. So please,
Okay.
just use your voice.
Okay, so now you still have like the opportunity to use the chat. Please do, because this is quite a complex topic, I understand. And I'm sure that maybe if you sleep it over and you will wake up tomorrow with some questions. In the meantime, I will just show you how this modeling works in practice. So now I'm going to use another data set, which is attrition predict. So this is, so what is the aim of classification, the aim of predictive modeling? It is, okay, Lori, I will answer your question just in a couple of minutes. Just let me finish this and I will get to your question. So the aim of classification, predictive modeling in general is training the model on old data and using it on some new unseen data to make decisions. So in the case of an online shop, I have some customers that didn't finish the purchase, and I have some data about these customers. I want for the future, for new customers, to say, okay, I need to give this person the discount so they will complete the purchase. And in the case of our HR department, I want to identify new employees, people I have not seen, and predict whether they will leave or stay. So here I have just like a small example how this would look like. I have 3 people, John, Rachel, and Veronica, and they have the same features as everybody else. So, I have all this data I need, but I don't have the attrition value. So I don't know, are they going to leave or stay? And now I want to predict this final value. So I'm going to use my model to predict this, which of these people will leave. So now I will just clear this for clarity. So I'm just keeping logistic regression, which was our best model. And I will use predictions to predict this data. So I'm going to use new data and the model that was built on existing data to make predictions. So here I see that logistic regression says John will leave and Rachel and Veronica will not. So this is the final goal, the end, so to say, labeling unseen data without labels with the help of the model. Okay, now to the questions. The first question, could I talk about implications of classification models? Okay, so this is what I touched just now. So classification models and regression models, they're aimed at training the model on unseen data and using this model to predict new data. The better the model, the better our predictions will be. In terms of business intelligence, this means improving our business, cutting costs, optimizing procedures, all sorts of things. So where is this used? So I come from laboratory of bioinformatics. We use it to identify factors of diseases, to identify which genes are more expressed in certain conditions than the others, for testing new drugs. So in terms of business, yes, so this would be used in identifying so valuable clients that you can convert, for optimizing business processes, so identifying risks in the production, perhaps predicting equipment failure, predicting like how to cut the cost of a certain production process, and so on. So this is a very broad field. You can use it in many different ways on many different domains. So, and why is it important to understand the model? I would say to make decisions. Explicable AI is a developing field. It's very popular, and there's been a lot of development in this section. Because while deep neural networks and other deep models, they work really well, the downside is that they're very difficult to interpret. And sometimes it's not important just to have a very, very accurate model, but it's also important to understand it, why things happen, because this helps you make decisions later, like as a decision maker. It gives you hints at why things happen. Another question is, are there any other classifiers available in the tool apart from logistic regression and naive Bayes? Yes, sure. So here in the model section, the pink section, you have all the models. So some are classifiers, others are regressors. Some do both, like random forest. It can be used for classification and regression, also KNN. So this is the collection of the models, and you can save and load them for later use. So perhaps just, Orange, by the way, is open source. It's free to use. You're welcome to download it and try it. The core components are those for predictive modeling, evaluating the models, and for unsupervised learning, so clustering, grouping the data, finding groups in the data. And then there are many specialized add-ons, so additional widgets that you can use for network modeling, for text mining, for example, for bioinformatics, for image analytics. So you can play around with the data as much as you want.
Is there any more questions from the audience? Okay,
So if things are not clear, you can always write to me. So if you're interested in using this software, or you want to know more about predictive modeling, I just wrote my email in the chat. You're also welcome to see introductory tutorials that we have on YouTube. I think we have 20 beginner level videos and some specialized content, so you can look at those to expand on today's topic.
Okay, thank you, Ida, for this really practical workshop. You replied all the questions that were raised during the lecture, but if there are some more, you can also use Huva app, where you can post questions, meet attendees and organizers, and raise a topic. So maybe you can also use that app. And as you will see the link in the chat, and I also have to, oops, just a moment. To conclude, just a few words about the event. UNI.MINDS is still going on, and it's organized by University of Ljubljana and University of Maribor by knowledge transfer and knowledge transfer offices. And it is, of course, with help from our industry partners. And it is also, it wouldn't have been possible without the support of the Republic of Slovenia and European Union under the European Regional Development Fund. We really hoped you enjoyed this workshop. Oops, okay, just a moment. It seems like my screen has been lost. Here you can see the agenda for the next few days. Please check it out and see where you feel most passionate about and join us. We'll be more than happy. But please do rate this session, because it will help us to do even better for the next events. And thank you for being here with us. It's been a pleasure sharing this knowledge. So take care, keep an open mind, and see you at some next event. Bye-bye.